On the next page of our Unit 2 review, we have our addition rules, conditional probability, and multiplication rule. It says number 7, 85% of high school seniors have a math class or government. Keyword here, right in the first sentence, math or government. This sets up our addition rule. So the probability of A or B equals the probability of A plus the probability of B minus the probability of both A and B. So our or, math or government, is 85%. It says 72% of seniors have math and 17% of seniors have government. If a high school senior is randomly selected, find the probability that he or she will have both math and government. So we get 85 equals 89 minus x. We subtract 89 from both sides. We get negative 4 equals negative x. So we get x equals 4%. So there's a 4% chance of picking someone, a senior, that has both government and math. Number 8, a card is selected at random from a deck of cards. What is the probability that it is either a club or a face card? This is the addition rule again. And there's overlap because you could have clubs that are face cards or face cards that are clubs. So we have the probability of event A plus the probability of event B minus the probability of both. The probability of picking a club, there are 13 clubs out of 52 cards. There are 12 face cards. Remember, this is only your jacks, your queens, and your kings. And then there are 3 that are both. Your jack of clubs, your queen of clubs, and your king of clubs. And this comes out to 11 out of 52, or 0.423. Number 9. 2 cards are selected from a standard deck of cards without replacement. Find the probability of selecting a 2 and then a jack. Assume the first card is not looked at before the second card is drawn. So on your first card, it says selecting a 2. You have a 4 and 52 chance. But it says without replacement. So now to pick that jack, you only have a 4 and 51 chance. So it comes out to 4 out of 663, or 0.006. Okay, number 10. We have our two-way frequency probabilities. Okay, so it says that we have a random sample of 500 high school students. The question was asked, do you like to purchase your lunch from the cafeteria? So I'm going to say buy and no to buying lunch. And we have males and females. We have 225 males. 190 of them said yes, they like to buy their lunch. We have 275 females. 160 of them said yes, they like to buy their lunch. Okay, so then we're left with 35 males that do not like to buy their lunch. And then we are left with 115 females that said they do not like to buy their lunch. And then we need total. We have a total of 350 people that like to buy their lunch. And then we have 150 people that said they do not. So the probability of picking a male. We have a total of 225 males out of 500. This comes out to 9/20, or 45%. A male and does not like to buy their lunch. Well, out of our 500 people, someone that's both male and doesn't like to buy their lunch is 35 out of 500. So this comes out to 7 out of 100, or 0.07. C is a conditional probability. Okay, so we know that we have somebody that likes to buy their lunch. We were given that. The total number of people that like to buy their lunch is 350. Now within those 350, how many are female? 160. D, the probability of picking someone that likes to buy their lunch, is just 350 out of 500. E, given that a female is selected, so we are given, that a male is selected, what is the probability he does not like to buy his lunch? Alright, so this time we were given that we have a male, so that's our denominator. We're only restricted to looking at 225 people because we know that we already have a male. Now within these 225 people, how many said they do not like to buy their lunch? 35. F, find the probability of selecting a person at random that is not male. Well, not male is the same as asking for a female, and that's 275 out of 500, which is 11/20ths, or 55%. G, find the probability of selecting a person at random that is male or someone that likes to buy their lunch. This is the addition rule. Keyword there, or. So we need the probability of a male plus the probability of somebody that likes to buy their lunch, and then we subtract our probability that somebody is both male and buys their lunch. So the probability of picking a male is 225 out of 500. The probability of picking somebody that likes to buy their lunch is 350 out of 500. And then the probability of picking someone that's both, again, that's where they overlap, 190 out of 500. So we get 77 out of 100, or 77%.